All right, welcome to the Explainer. Today we're diving straight into a super fundamental coding skill, JavaScript loop control. By the time we wrap up here, you're going to know exactly how to command your data flows using some really practical code examples and a few simple analogies. Let's get started. So here's the big question for us today. How do you actually interrupt a loop once it starts running? You know the scenario. You've built your loop, it's crunching through data, but suddenly you absolutely need it to stop. Maybe it's to save memory, or maybe you need to change behavior based on a specific event. Okay, let's dive into this. But before we start interrupting things, we need to quickly remind ourselves of the nature of a standard loop when it's left entirely to its own devices. Think of a standard for loop like a highly predictable road trip. You initialize, basically starting the car, then you check your condition, execute, and increment. As you know, if left to its own devices, this loop just marches predictably forward from point A to point B, 0 to 9. It's reliable for sure, but it's completely inflexible. The journey only ends when that natural condition is finally met. But hey, code, just like life, doesn't always go exactly as planned, right? We run into exceptional circumstances. These are specific conditions in your code where that normal, highly predictable forward march needs an immediate interruption. Imagine you're on that predictable journey, but suddenly, boom, you hit a massive roadblock. Or think about a real-world coding scenario. You realize you've already found the exact user you were searching for in a massive database. Continuing to search the rest of that database is just a massive waste of processing power. You need an emergency exit. To handle these specific snags, JavaScript gives us two very special keywords. The first tool in our emergency toolkit is the break keyword. And break does exactly what it sounds like. It breaks you out of the loop for good. Think of it kind of like a party ending early. You don't linger, you don't go check the next room, you literally just grab your coat and exit the building immediately. When JavaScript reads the word break, the loop is terminated instantly, regardless of what the original condition was supposed to be. And this brilliantly illustrates how simple it is to implement. Setting up this emergency exit is super straightforward. We just drop an if statement right inside our loop. We're telling the engine, hey, while you're looping, if you ever hit the number 7, trigger the break keyword. We are manually grabbing the steering wheel and forcing the loop to stop based on our own custom rule. We're completely overriding the loop's original boundaries. Because that break condition is in there, the output changes dramatically. The loop hums along, printing 0 through 6, but the absolute second the index hits 7, our if statement catches it. The break keyword is triggered, instantly killing the loop. It completely bypasses 7, 8, 9, and literally anything else that was supposed to come after. The party's officially over at 6.
So, you might be wondering, where exactly does the code go when it breaks? Well, it doesn't crash your program. Actually, the JavaScript engine simply drops down and moves directly to whatever code exists immediately following the loop. We seamlessly bypassed the unnecessary remaining cycles of that specific loop, saving processing time, and our overarching application just keeps running perfectly fine. The whole shebang stays intact.
But what if you don't want to cancel the whole party? Let's move to and see how this builds our next concept, the continue keyword. If break is the emergency exit, continue is really just a quick detour. It is essentially a weak format break. It tells the engine, hey, skip the rest of the code for this specific cycle and instantly jump back up to the top to start the next iteration. You're gracefully ignoring the current step, but you are not abandoning the whole journey.
Let's look at the exact syntax we used for that detour. Let's say 3 and 5 represent corrupted data points, or maybe invalid entries from an API response that we just want to ignore. We tell the code, if our index hits 3 or 5, hit continue. The loop gracefully skips our execution logic for those specific bad inputs and jumps straight back up to increment to the next number. It safely steps right over the problem. Now, what's really interesting here is how comparing these outputs side by side perfectly cements the difference between the two. With break, we count up to 6, and the loop is utterly destroyed. It served its purpose and ended early. But with continue, the loop actually finishes its overarching job all the way up to 9. It gives us the surgical precision to completely skip the iterations for exactly 3 and 5. The overarching process survives, just with a few carefully planned detours. So the crucial point is this. Your golden rule for loop control boils down to one simple phrase. Use break to stop and continue to skip. If you memorize that simple distinction, you'll always know exactly how to handle data exceptions efficiently. Do you need an absolute emergency exit to save performance? Break. Do you need a minor detour to bypass irrelevant or corrupted data? Continue. And that brings us to the end of our journey today. But I want to leave you with this final thought to chew on. What exceptions will you control in your next project? Seriously, look closely at the loops in your own codebase. Could an early exit or a quick skip make your program significantly faster and more resilient? I highly encourage you to experiment with these tools and take total control over how your data flows. Thank you so much for joining this explainer, and happy coding!